Ignition Fundamentals by Mr. N. Kumarasan. An ignition system is a system for igniting a fuel-air mixture in petrol, gasoline, engines, to supply a spark inside the cylinder, near the end of the compression stroke, to ignite the compressed charge of air-fuel vapor. To develop a high-voltage spark and deliver the spark at correct time according to firing order, it has to produce a high-voltage spark, 8,000 to 30,000 volts, for a small duration at correct intervals of time, between the electrodes of the spark plug. A spark at atmospheric pressure requires only 8,000 volts, but at compression pressure of 5 to 10 kg/cm requires 20,000 to 40,000 volts to initiate combustion. For a spark to jump across an air gap of 0.6 mm under normal atmospheric conditions, 1 bar, a voltage of 2 to 3 kV is required. For a spark to jump across a similar gap in an engine cylinder, having a compression ratio of 8:1, approximately 8 kV is required. For higher compression ratios and weaker mixtures, a voltage up to 20 kV may be necessary. The ignition system has to transform the normal battery voltage of 12 V to approximately 8 to 20 kV and, in addition, has to deliver this high voltage to the right cylinder, at the right time. Some ignition systems will supply up to 40 kV to the spark plugs. Design considerations. When considering the design of an ignition system, the following factors must be taken into account: combustion chamber design, air-fuel ratio, engine speed range, engine load, engine combustion temperature, intended use. Additional design considerations: minimal flame travel. The exhaust valve and spark plug should be close to each other. Sufficient turbulence. A fast combustion, low variability. High volumetric efficiency at wide open throttle. Minimum heat loss to combustion walls. Low fuel octane requirement. 3 types of ignition systems: 1. Magneto-coil ignition system. 2. Battery coil ignition system. 3. Solid-state ignition system. Ignition system requirements. The ideal ignition timing is dependent on 2 main factors: engine speed and engine load. An increase in engine speed requires the ignition timing to be advanced. The cylinder charge, of air-fuel mixture, requires a certain time to burn, normally about 2 milliseconds. At higher engine speeds, the time taken for the piston to travel the same distance reduces. Advancing the time of the spark ensures full burning is achieved. A change in timing due to engine load is also required, as the weaker mixture used on low load conditions burns at a slower rate.